these next examples, we'll talk about how to solve initial value problems and separable equations. So in number 25, we're given that dy dx is equal to 1 plus x squared over 2, with the initial condition of y of 0 equals 1. So I'm going to rewrite this as dy is equal to 1 plus x squared over 2 dx. And so from there, when we integrate both sides, we're going to get that y is equal to x plus x squared over 2 plus 1/2 times x cubed over 3 plus c. So you get y is equal to x plus x squared over 2 plus x cubed over 6 plus c. And then plugging in our initial value, we're going to get that 1 is equal to 0 plus 0 squared over 2 plus 0 cubed over 6 plus c. So c is equal to 1. And then all we have to do is rewrite it using our initial condition. So y is equal to x cubed over 6 plus x squared over 2 plus x plus 1. Moving on to number 26, we're going to get the dx to the other side. We get dy is equal to x plus 1 over x squared dx. And I get dy is equal to, I'm going to combine these fractions. So this is going to be x over x plus 1 over x squared. So dy is equal to x squared plus 1 over x quantity squared dx. So dy is going to be equal then to x to the 4th plus 2x squared plus 1 over x dx. So dy is going to be equal to x squared plus 2 plus 1 over x squared dx. So we get dy is equal to x squared plus 2 plus x to the negative 2 dx. And then I'm going to integrate both sides. And I get y is equal to 1/3 x cubed plus 2x minus x to the negative 1 plus c. So y is equal to 1/3 x cubed plus 2x minus 1 over x plus c. And then using our initial value of 1, 1, I get 1 is equal to 1/3 plus 2 minus 1 plus c. So I get 1 is equal to 1/3 plus 1 plus c. I subtract 1 from both sides. 0 is equal to 1/3 plus c. So c is equal to negative 1/3. And then rewriting our equation, we get y is equal to x cubed over 3 plus 2x minus 1 over x minus 1/3. Moving on to number 27, we get that dy is equal to 1 over t plus 4 dt. So using a u sub, we get that the integral of 1 over t plus 4, we're going to let u equal t plus 4 and get du equals dt. So this becomes the integral of 1 over u. So this becomes ln of u plus c, which is ln of t plus 4. So when I integrate both sides, I get y is equal to ln of t plus 4 plus c. So I'm going to use our initial value of 2 comma negative 3. So I get negative 3 is equal to ln. I get 2 is equal to ln negative 3 plus 4 plus c. 2 is equal to ln of 1 plus c. So 2 is equal to c. So then our function y is equal to ln of t plus 4 plus c. And I can drop the absolute value bars because my x value is positive. Number 28. we get that dy is equal to cosecant of 2 theta cotangent of 2 theta d theta. So we're going to integrate both sides, and to do that we're going to need a u sub. So the integral of cosecant 2 theta cotangent 2 theta, I'm going to let u equal to theta, so du is equal to 2 d theta, so 1/2 du is equal to d theta. So this becomes the integral of 1/2 cosecant u cotangent u du. So this becomes 1/2 times negative cosecant of u plus c. So negative 1/2 cosecant of u plus c. So we get negative 1/2 cosecant of 2 theta plus c. So back to our original problem, we get y is equal to negative 1/2 cosecant of 2 theta plus c. And we're going to use our initial condition of y of pi over 4 equals 1. So we get 1 is equal to negative 1/2 cosecant 2 times pi over 4 plus c. So this would be cosecant of pi over 2 plus c. 1 is equal to negative 1/2. Cosecant of pi over 2 is just 1 plus c. So we get 3/2 is equal to c by adding 1/2 to both sides. So y is equal to negative 1/2 cosecant 2 theta plus 3/2. Skipping a couple problems, moving on to number 31, we get 1 over y plus 2 dy is equal to dx. So when you integrate both sides, you're going to get ln of y plus 2 is equal to x plus c. We have to raise both sides to the e, and we get y plus 2 is equal to e to the x plus c. So y plus 2 is equal to e to the x times e to the c. And we're going to let e to the c just be some constant c. And then we're going to use our particular solution, y of 0 equals 2. So then we get 2 plus 2 is equal to c e times to the power of 0. 4 is going to be equal to c. And so we get y plus 2 is equal to 4 e to the x. So y is equal to 4 e to the x minus 2. Moving on to number 32. We get that 1 over y plus 1 dy is equal to 2x plus 1 dx. So when you integrate that, you get ln of y plus 1 is equal to x squared plus x plus c. So we need to raise both sides to the e. And we get y plus 1 is equal to e to the x squared plus x plus c. So y plus 1 is equal to e to the x squared plus x times e to the c. Y plus 1 is equal to, I'm going to call e to the c just c, times e to the x squared plus x, using our initial condition of negative 1, 1. We're going to get negative 1 goes here, plus 1 equals c times e to the negative 1 squared minus 1. So 2 is equal to c e to the 0. So c is equal to 2. So you get y plus 1 is equal to 2e to the x squared plus x. So y is equal to 2e to the x squared plus x minus 1.